Hello. I know you people have studied arithmetic progression, and very close to it is the geometric progression. Now, what is a geometric progression? As I've told you, close. Can you just think? Something which changes the most fundamental thing. No? Well, I'll tell you. Now, in an arithmetic progression, you used to add to the last term a specific number. And then, again to get to the next number, you were adding that fixed number. And here in a geometric progression, in place of you adding, now you will be multiplying by a specific number. Now let's cut the cake and let's try and understand this in an easier way. So if say you have something like a, which is your first term, and let's say the number with which we want to multiply to get to the next term is r. So as such, a when multiplied with r will give you the next term. And then again, if you multiply this with r, that is ar multiplied with r will give you the next term, and all of this is going to continue. Now children, if we look up here, you have this to be the first term, you have this to be the second term, and you have this to be the third term. Let's refine this. Now when we refine this, we get the first term to be a, however the second term is ar, and the third term becomes equal to ar square, right? As we know that here we have the first term, the second term, and the third term. So I'd like you people to see something. Can you see something which is happening? Yes? No? Well, let me tell you, we are getting to see that if we are talking about the nth term, right, we are getting to see that there is one less that number n, the number of r, that is the common ratio. So the power of r will be one less than the number of terms. So as such, here if we talk about T4, it's going to be pretty simple. We will have it to be a r, one number less than this number 4, that is it will become equal to 3. Now from this, children, we get the formula with the help of which we will be able to find out any term of a geometric progression, and that, children, comes out to be something like this. That is, we have Tn, which is given by a, which is further multiplied with r, and its power should be one less than this n, that is n minus 1. Now like we looked up in AP, here too, if we talk about the nth term, then the nth term can be said to be the last term. As such, we also write this with small l, right? So this is the basic concept of a geometric progression. That is, in order to get to the next term, you just multiply by a fixed number, right? And this always happens, and because this always happens, there is another thing that we can write. That is, if say we talk about, say, the second term and we divide it by the first term, that is going to be equal to the third term when it is divided by the second term, and all of this process continues for any two consecutive terms where we divide the later term by the earlier term to get r, which, children, is the common ratio. So here at this time I will be writing what this r is. This is actually what? This is the common ratio. Yeah, you are very correct. If we talk about the arithmetic progression, it was the common difference, and now here it is the common ratio. So all of this, children, that I have just discussed, I will rediscuss so that if there is any doubt you people have, all of that gets cleared. Now children, here we are talking about geometric progression. Now the only difference that geometric progression has from an arithmetic progression is that to the first term there is a number multiplied rather than be added, right? And when that number is r, that is the common ratio, right, you get the second term. Now to the second term, again that same number r, if it be multiplied, that becomes the third term. Now here we can see a pattern in T1, T2, T3 that we can apply for T4. That is, the first term a is there in all of the terms, and if we talk about the common ratio, then the power of the common ratio is one less than the number of terms. Like this is the fourth term, and in the fourth term the power of 1 less, that is, it is 4 minus 1, or in other words 3. So we have AR cube to be the fourth term. Now from this emanates, or from this comes over, the formula for finding out the nth term of a geometric progression, and that is Tn is equal to A times of R raised to the power n minus 1, and that, children, is said to be the last term. As such, we also write it by small l. Right, now remember here, children, there is this basic characteristic, right, which helps us in determining the series or the progression to be a geometric progression or not. So here, when we talk about the geometric progression, the characteristic property is that if you divide the later term by the earlier term, obviously the consecutives, that means one after another, then you will say that you will get the common ratio. So here, if we divide the third term by the second term, or if we divide the second term by the first term, or even if we divide the 20th term by the 19th term, we will get the common ratio, and children, it is represented by small r. So is everybody clear about all of this? This is pretty simple, right? So now, children, to be able to understand this, now we have a sum that we will tackle, and I'll tell you everything about it. But initially, what I like from you people is, I like you people to give it a good try, right? And after that, I will be discussing the sum with you people. So now at this time, I expect you people to start trying out the sum, right? And I obviously will be able to give you little time. I'll just be able to give you some 10 seconds, right? Moreover, what you can do is you can pause this lecture for a longer duration and you can give it a proper valid try. Remember, every time you try, even if it is very difficult, your intelligence level increases. So do give it a proper try, right? And if you study in this way, I can assure you that in times to come, you will become really intelligent, capable, and you'll be able to memorize what the concepts are. You'll be able to analyze and apply the correct concepts at the correct place. Okay, so let's get started. Five seconds remaining. Right. So children, here we have this sum in which it has been given to you. Now, I obviously expect that you people must have tried out the sum properly, and now you're seated to get to see the solution, whether matches yours or probably you just couldn't do even a little, and now you are watching intently the solution. So after you watch the solution intently, I will be giving you a second explanation so that if there are any doubts, all of that gets cleared. However, you also require to do one thing more, that is you require to practice this once more immediately, and then that is going to sit very well in your brain. So children, in this question, we've been given that if we have the p plus qth term of a geometric progression to be m, right? So here, as we are going to use some specific number term of the geometric progression, we will first write what the formula is. So we can now say that if we talk about, say, the nth term Tn, then that is equal to A, which is multiplied with R, the common ratio, raised to the power n minus 1. Now, using this, we can now write the p plus qth term, which has been given to us to be m, right? So Tp plus q is equal to m, and further that, children, is equal to, say, some first term A multiplied by the common ratio R, which is going to be raised to one number less than the nth term, that is the p plus qth term. So it is going to become equal to AR raised to the power p plus q, from which minus 1 is to be subtracted, right? So as such, this then becomes the first equation, right? And we'll mark it to be the first equation, and in times to come, we will find out the unknowns. Now, can you tell me at this time what are the two unknowns? Yes, you're very correct. The first unknown, children, is A, that is the first term, and the second unknown is R. So here we are considering that this P and q are just like constants, just like numbers. So they might be just like 4 plus 3, right, or 4 minus 3, right? So you will consider these numbers which have been given to you like constants. And if you talk about m and n, the same thing, that is, they are also constants. However, as we have to find out a and r, right, without that you will not be able to find any specific term. As such, they are the variables, right? Now when we go to higher maths, we normally do not consider numbers as constants. We use other alphabets to be just like constants. Obviously that does increase the complexity of the sum, but that is what the teacher wants to detect, whether if complexity increases, whether you will be able to pass the test or not. So make sure you are comfortable with constants written like alphabets. So when you have expressions, there will be constants as well as variables which are both alphabets, and you will have to differentiate what are constants, what are variables, and then tackle them with ease, because you know that constants values are known and you just have to find out the value of the variables. Okay, now children, we'll talk about the second equation that can be formed. So here we have p minus qth term of the GP, which is n, right? So here children, as the p minus qth term has been given to you to be n, so in a similar way we can again now write that you have t p minus q, right, which becomes equal to n, right, and that further can be written as a further multiplied by r raised to the power p minus q minus 1. Now children, as this is entirely different, so we will mark this to be equation number 2. Now we get to see that we have two equations and there are two unknowns. I hope you can easily see it, so I'll just mark it and show it to you. That is, the first unknown children is a, right, which is there in both the equations, and the second unknown is this r, which is again in both the equations. So elimination will be best, and I'm sure you can tell me how we are going to eliminate one variable. That's pretty simple. Yeah, please tell me. Aditya, Krishna. Very good, Hashir, you've told correct. That is, when we divide the first equation by the second equation, we will actually be able to eliminate the variable that is a. I really am to appreciate your concentration, Hashir. This is how you concentrate intensely, exactly where the teacher's pointer is. So if I'm writing 2, you should be at 2. If I'm making the circle to encircle 2, you should be there. And if your focus is like that, and if you're sitting on a table and chair such that you are doing nothing, I said nothing, right? That means no mobile, no TV, no relatives, no friends, and you are focusing in a concentrated way, in a quiet place, then I'm sure you'll understand everything with utmost ease. Okay, so for the children, as Hashir has told us, what we are going to do is we will now be dividing the first equation by the second equation, and then we will get to see that the variable a will get liberated, or in other words we can say that it will pass away, or we can say that it will actually be removed, right? So now if we write our step, we will write it again with a different colored ink so that the examiner understands that this is the step that next we are going to undertake, right? In your case, you can use black pen for writing the headings, and you can do your work in blue ink. Well, when we are to divide the first equation by the second equation, now children, we will get from the left hand side m, which is going to be divided by n, and on the right hand side obviously we have a, which is multiplied with r raised to the power p plus q minus 1, right? And in the denominator we have a, which is further multiplied with r, which is raised to the power p minus q minus 1, right? So children, this is how we will have the ratio of both of these equations. And next, now what you'll do is we will be simplifying this. That means we will be cancelling off those terms which can get cancelled. So obviously this a will get cancelled pretty simply. However, if we talk about r, then we'll be using a rule of indices. That is, if you have some a which is raised to the power m and it is divided by, say, some a which is raised to the power n. So here we see that if you talk about the bases, if they are the same and there is some index with the number in the numerator and there is another index with the number in the denominator, then we can use this quotient rule of indices to write this as a raised to the power m minus n. I'm sure you people must have learned this in class 8 or probably class 9. Right now we're going to apply this rule as such. Next, now we will now be having m upon n as it is, and here then we will have r which is raised to the power p plus q minus 1, from which you will be subtracting the power of the denominator, that is p minus q minus 1. Right now, next children, we will be solving this out. So this is going to become equal to m upon n here, and then we will have r which is raised to the power. Again, now we are going to cancel off the terms which are additive inverse of each other. As such, we will have p which will get cancelled with b, we will have q which will get cancelled with q, right? And then further we will have, rather we get to see that if we talk about q, it is not getting cancelled. Why? Because if we see q here, right, contrary to what p was, here we had plus p and then we got minus p. So as such, both of these got cancelled when we multiply the minus sign inside. However, if you talk about q, then we have q minus minus plus q. As such, it will become 2q, right? So you have to be very cautious while cancellation, right? Or you can increase one step. Obviously that will help you in not making mistakes. Now for the children, here we get to see again, if you talk about 1, then you have minus 1 here, and then you'll have minus minus plus 1, right? As such, both of these ones are also going to get cancelled, right? And thus you will just be left out with r raised to the power 2q. I'm sure you people must be pretty relaxed because things have become simpler than earlier. So next now children, after this, what we do is, if we are to find out the value of r, what we do is we take the 2qth root of both the sides. So this is what we are going to eventually write, that is taking 2qth root, right? So if we do so children, next now we'll get here m upon n, right, whole raised to the power 1 upon 2q, and on the right hand side what we'll get is we will get r raised to the power 2q, which is already there, and it will be raised to 1 upon 2q. Now children, here I will quickly remind you of a formula that you have studied in indices, which is the power formula. That is, if you have some a raised to the power m which is raised to the power n children, then that becomes equal to a raised to the power m which is multiplied with n, right? So using this rule, now we will have on the left hand side obviously m upon n, which is whole raised to the power 1 upon 2q, and if you talk about the right hand side, it then becomes equal to r, which is raised to the power 2q, and it will be multiplied by 1 upon 2q, which was the whole power, right? Now children, here we get to see that we can actually cancel off this 2q and this 2q, right? As such, we will have r raised to the power 1, and to get it, actually we've done this step, right? So now we get the value of r, which remember is one of our variables, and we get it to be m upon n whole raised to the power 1 upon 2q. Okay, so having the value of r, our next task is to find out the value of the other variable. So Radhika, can you tell me what the other variable was? Very correct, it was actually a, right? So if we go back to the equations that we made, we remember that in the first equation we had a, which was one of the variables. So we will write this equation, and in this then we will substitute this newly found out value of r, right? So now children, as we now talk about equation number 2, so we will rather write this equation number 2, and in it we'll do the manipulations. That is, we now had, we are using equation number 1, although we can even use equation number 2 there is no problem, but we just looked up equation number 1, right? That's why we will be writing equation number 1, right? So equation number 1 is what we're going to write, okay? And we will now put in it the value of r. Okay, now children, if you remember, the equation was m, which is equal to a, which is further multiplied with r, right, and is raised to the power p plus q minus 1, right? So here, as we've got to find out a, so we'll make it the subject of the equation. So we'll have a to be equal to m, which will be divided by r, which is raised to the power p plus q minus 1. Right, now children, we'll keep the value of r. You remember the value of r was m upon r n raised to the power 1 upon 2q, right? So this value is what we're going to substitute. So now we will have a, which will become equal to m, which is further divided by m divided by n whole raised to the power 1 upon 2q. And remember, the whole power of r was p plus q minus 1. So we will write the whole power to be p plus q minus 1, right? Now children, next what we have to do is, as we see that n is in the denominator of the denominator, so it will come over to the numerator. I'll show you how. So if, say, you talk about a upon b, which is whole divided by c upon d, then obviously you can write this as a upon b, which is divided by c upon d, to simplify things. Next, now children, this can be written as a upon b. The division sign will now be converted to multiplication sign, and then you'll have the reciprocal of the fraction which has come next, that is d upon c. Similarly children, here if you see this n, right, as this is m divided by m upon n, so we will have the term with n which will reciprocate to the top, and the term with m will remain in the denominator. Next, now children, let's first make what these numbers m and n will have powers as. So in the next step children, we have now m, right, which is divided by m, now raised to the power. I'll rather write this m a little below, because this power should also be written in a large way. So as you see, this is going to become p plus q minus 1, right, which will be divided by 2q, right? That is because we've seen it earlier that if we have some a raised to the power m, which is whole raised to the power n, then we get this to be a raised to the power m into n, right? So that is why here too we have multiplied both of these powers, and this is what it becomes. And in the denominator children, what we have is, we will again have the power of n in a similar way to be p plus q minus 1, which is going to be divided by 2q. Right, now children, as I've already discussed, the power of n will come over the numerator just as it is, as it will reciprocate, right? So we will have n, which is raised to the power p plus q minus 1 raised to the power 2q. And if you talk about the power of m, right, in the numerator, when there is no power, it automatically means that the power is 1, right? I have written here, right? So from the power 1 is going to be subtracted the power in the denominator, that is p plus q minus 1, which is divided by 2q. Now why has this been done? That's because if, say, you now talk about this rule that we have in indices, that is when we talk about a which is raised to the power m, which is divided by a raised to the power n, that is the bases are the same, then keeping the base to be the same, we subtract from the power of the numerator the power of the denominator, right? So we've used this rule here, and now as such we will now further just simplify this, and that will become our answer. So we can now write m first, and then as we take an LCM, which will be 2q, right, and then further we will have 2q, right, from which is going to be subtracted p, q and minus 1, which will become plus 1, right? That is because children, here this p plus q minus 1 is actually multiplied, right, with this minus sign. Now here we get to do a little bit of simplification, and we find that we can actually cancel off one of the q's. So this is going to become equal to q, right? And then we have minus p plus 1, which will remain to be as it is. Next, now we write what n is going to become, and obviously n will stay to be the same, that is n raised to the power p plus q, right? And from that is going to be subtracted 1, right? So this, children, is what the power of n is. So we now have our a, although it's a little long, but even then this is what it is. Now you don't forget that the denominator of this is 2q also, right? So as such, we now have the value of a, which is m raised to the power q minus p plus 1, right? And further, the power of n, which is p plus q minus 1. Now that we have the value of a and r, we can find out what we require. Now, children, what do we require? We actually require, by the question, this thing that we have here, this thing that is, we have to prove that the pth term is root mn. So now we'll be able to find out any term, and here we've got to find out the pth term, and we've got to show that that is root mn, right? So writing out the pth term, so we will have now the pth term, which can be written as, first we'll write what we have to prove. So we'll rather say that to prove that what it is TP, which is equal to root mn, as simple as that. So we'll have to use up all of these values, that is the values of a and r, to find out the value of the pth term, right? And as children, we have already discussed that if we require to find out the value of any term, we have the formula for Tn, right? And what was that? Tn is equal to a into r raised to the power n minus 1. So next, now we'll be finding out this, that is, it is going to become equal to Tp, which is going to be a into r, which is going to be raised to the power p minus 1. Right? I'm sure you people are getting a little nervous as things are becoming a little longer. They're taking a lot of time, but don't you worry. When you practice, you'll be able to do this with ease very quickly, right? Why am I taking time is I'm trying to make everything which comes in the way, which might stumble your understanding, to be perfectly clear, writing that with the different colored ink so that you can perfectly understand this. And obviously, understanding this for the first time is going to take some time. However, when you practice, you will smoothen things out and your pace will also increase. Okay, so if we talk about the pth term, children, this is then going to become equal to a. We just found out the value of a to be m, which is raised to the power. Now remember, children, both of these are divided by 2q, and that is something that we can't forget, right? Okay, I'm sorry that I forgot. Okay, so we have m, which is raised to the power q minus p plus 1 whole raised to the power 2q, and the power of n is p plus q minus 1, which is divided by 2q. Okay, so this is what a is, and we already know what the value of r is. It is m upon n, which is raised to the power 1 upon 2q. We will quickly affirm whether this is actually correct or not. That is the value of r. We have the value of r to be m upon n raised to the power 1 upon 2q, so I am absolutely correct, right? So now further, remember that the power of this also has to be how much? It has to be p minus 1. Can you see? A, which has been multiplied with what? A, which has been multiplied with r raised to the power p minus 1. So we'll put the whole power to be how much? We'll put the whole power to be p minus 1. Next, now children, what we do is we will now have to solve out these powers of m and n. So m raised to the power q minus p plus 1, right? And this, children, is divided by 2q, right? And except that, we will also get the power of m to be p minus 1, right, divided by 2q as we get it from here, right? Again, here that rule is going to apply, that is a raised to the power m whole raised to the power n will become a raised to the power m into n, and both of these numbers will get multiplied, which are in the powers. Now if we talk about the power of n, then that is p plus q minus 1, and children, this is divided by 2q, right? And now if you talk about the power of n in the denominator, it is what? It is n, which is raised to the power p minus 1, and it is divided by 2q. All right, okay, now children, we look up how we can solve out the powers of m and n, and here for that you'll have to remember two rules. That is, if you talk about a raised to the power m which gets multiplied with a raised to the power n, then keeping the base to be the same, we will add the indices, that is a raised to the power m plus n. Nextly, we have another rule, that is, if we talk about a raised to the power m which is divided by some a raised to the power n, then that becomes equal to a raised to the power m minus n. So here as such we will be now talking about this. So the power of m is going to get added and the power of n will get subtracted, right? So what is the power of m? It is in the first term to be q minus p plus 1, which is divided by 2q in its first representation, and then in its second representation as it is p minus 1 upon 2q. So we're going to add it as we have some m which is raised to the power a multiplied with m raised to the power b, right? So it will become m raised to the power a plus b. Next, now children, if we talk about n, we find that one number which represents n raised to the power something, it is divided by another which is n raised to the power something else. So as such, here by looking up the second rule, right, we will now write again n, and its power will become the difference of both of these numbers, that is p plus q, from which 1 is subtracted, divided by 2q, and from that, children, is subtracted p minus 1 divided by 2q. Right. So next, children, what will happen is we have to simplify these. So we will now simply simplify it, right? So we have m, which is now whole raised to the power 2q is what we can write as the common denominator is like that, right? And then, children, we have q minus p plus 1, right, as the denominator is exactly the same. So as such, we can copy the rest, that is p minus 1. Now here we find that, children, that we have numbers which can get cancelled, like minus p and plus p will get cancelled, plus 1 minus 1 will get cancelled, and as such we will just be left out with q in the numerator. Now coming over to n, we have again the whole denominator which can be written to be 2q, and in the numerator we have p plus q minus 1, right, from which is to be subtracted p minus 1. So obviously p minus 1 is the numerator of the second fraction, so both the numbers require to be multiplied by minus sign. This is a common mistake which children make, and due to which they lose marks, right? Remember, if there is a fraction, both, if there are two terms, will get multiplied by minus sign. If it is minus outside, if there are 3 or 5 terms, all of the terms will be multiplied by minus sign if it is outside, right? So here as such, again we get to see that there are certain terms which can get cancelled, right, like minus p and plus p, and we have minus 1 and plus 1 which get cancelled. So we will now just write what is remaining. So what remains is m, which is raised to the power q divided by 2q, and similarly we have n raised to the power q, which is divided by 2q, exactly the same, right? And all of those fantastic big numbers just got reduced to something which is very small, right? Now children, we will talk about cancellation further. We get to see that now again we can cancel, and here we have this q which will get cancelled with this q, and we have this q again which will get cancelled with this q, and thus we are just left out with m, which is raised to the power 1 upon 2, and n, which is also raised to the power 1 upon 2, and Thus we can write this as m into n, right, which is raised to the power 1 upon 2. Now here I like to tell you two facts. The first is this, that if you talk about a which is multiplied with b which is whole raised to the power n, then that becomes equal to a raised to the power n into b raised to the power n, right? And similarly, if say we talk about the other rule that I want to discuss, that if say you have say a square root, that means the whole power is 1 upon 2. So if say we now talk about some a whose power is 1 divided by 2, then that actually means that that is the square root of a. Likewise, if say we would have had the power of a to be say 1 upon 16, so it would have become the 16th root of a. That is, in this valley-like structure you write 16. Okay, now children, after this we will now write what they actually have become. That is, we now have root of mn, right, which becomes the final answer. And if you remember, this children is what we had to bring, right? So we will quickly look this up, right? So now looking this up, we have here what we have here, the proof, which I quickly want to show you that this is what was required to be found out. That is, you had to show that the pth term is root mn, right? So all of this I will quickly discuss, so that if there is any doubt withstanding, all of that gets clear. So children, in this question you had been given that the p plus qth term of a gp is m, right, and the p minus qth term of the gp is n, right? And you have to prove that the pth term is root mn. Remember, there is another second part which I like you people to try, although I will also be discussing it. Now when we have this p plus qth term to be m, as we know that Tn is given by a into r raised to the power n minus 1, so Tp plus q will become m as is given, so it will be a into r raised to the power p plus q minus 1. Now the p minus qth term is n, as such it will be written to be a into r raised to the power p minus q minus 1. Just a second, guys. Okay, now let's quickly have a second explanation, so that if there is any doubt withstanding, all of that gets cleared. So here children, we have been given that there is a geometric progression, and you already know what a geometric progression is, and in that we have the p plus qth term, which is m. So as we know that Tn is equal to a times of r raised to the power n minus 1, so the p plus qth term is going to become equal to m, which has been given to you, is a times of r raised to the power p plus q minus 1. That means whatever the value of this n is, from that we subtract 1. Next, now after this what we do is we also have the p minus qth term which has been given to us, and that is n. As such, n, which is the p minus qth term, can be written to be equal to a r raised to the power p minus q minus 1, right? Now after this children, next what we do is we now talk about removing one of the two variables. Like we've already discussed, there are two variables here. One of the variables is a and the second variable is r. We've got to treat p, q, m and n like constants, that is just like numbers. So when we talk about removing one of the variables, a very easy way can be that if we divide the first equation by the second equation, then a and a will get cancelled, and then we will have the equation all in terms of r, which is one of the variables. If we can make that the subject of the equation, we can get the value of r. So for the children, next what we will be doing is we will now be talking about dividing both of these equations, and in that we get to see that on the left hand side we will have m upon n, right, and on the right hand side a gets cancelled, right, and then we have something like a raised to the power m divided by a raised to the power n, something like this. So obviously that becomes equal to a raised to the power m minus n, right. Here too we will have the power of r, which is in the numerator, from that we are going to subtract the power which is in the denominator. So we get to see in that we have p plus q minus 1 which was there in the numerator, and from that we are subtracting the power of the denominator, that is p minus q minus 1. So here children we get to see that p and minus p get cancelled, minus 1 and minus times of minus 1, that is plus 1, get cancelled, and then we are just left out with q, right, and minus minus plus q, that is r raised to the power 2q which is remaining. So now on the left hand side, as we already had m upon n, so we can make r the subject of the equation if we take the 2qth root of both the sides. So if we take the 2qth root of both the sides, we will now have here 2qth root, meaning that whatever is there, the power will become 1 upon 2q. So we have m upon n raised to the power 1 upon 2q, which will further equal to r raised to the power 2q whole raised to the power 1 upon 2q. Right? Now children, remember the power rule of exponents. That is, if you have a raised to the power m which is whole raised to the power n, then that becomes equal to a raised to the power m into n. So here too, obviously the power of m and n both will become 1 upon 2q, but if we talk about the right hand side, we will have 2q which will be multiplied with 1 upon 2q, where both of these will get cancelled as they are in multiplication. So on the right hand side we will just have r, which can be written as r to be equal to m upon n raised to the power 1 upon 2q. Now after this children, we will get to the first equation, and now substituting this value of r, we will be able to get to the value of a. So as such, we get the value of a from the first equation, remember, right, which was this, that is, we have m, that is the p plus qth term, right, which now becomes equal to what, which then becomes equal to a, which is the first term, times of, we have r, right, which is raised to the power p plus q minus 1, right. So as such, here we now have the value of this m, right, which is equal to a, the first term, times of the common ratio r, right, which is raised to the power p plus q minus 1. Now further here what we do is, if we talk about this, then here we can make a the subject of the equation by dividing this m, right, by this power of r. So as such, we will now cross multiply this and make a the subject of the equation. So now we have a to be equal to m, which is divided by r raised to the power p plus q minus 1. But remember, we have the value of r to be m upon n whole raised to the power 1 upon 2q, that we are going to substitute here. So in place of r, now we have m upon n raised to the power 2q 1 upon 2q and its whole power as it is p plus q minus 1. That is what we will write here. Now next children, what we will do is, as we have m in the numerator and in the denominator also we have m, so if we have some a upon b which is divided by c upon d, then that becomes equal to a upon b. In place of this whole denominator sign, we can write the division sign, and then we have another fraction. Now in the next step, we can write the first fraction and convert the division sign to multiplication sign, and then write the reciprocal of the fraction which is next. So that will become d upon c from c upon d. Now next children, here we get to see that if we now bring this fraction to the numerator, it will actually become n upon m, and these powers will remain as it is. So first we'll solve these powers, as again here the power rule of indices gets applied. So here both of these powers are going to get multiplied, and as such we will now have m, which will be raised to the power p plus q minus 1 whole divided by 2q, and there will be in the denominator again the power of n to be the same, that is p plus q minus 1 divided by 2q. Further, when we reciprocate, obviously this will come to the numerator as it is, and this will come to the numerator with minus sign. Or we can do another thing, that is, if we remember the quotient rule of exponents, if we have a raised to the power m, which is divided by a raised to the power n, then that, children, becomes equal to a raised to the power m minus n. So here too, whatever is the power of the denominator, that is going to get subtracted. As such, here we will have m raised to the power 1, as it is just m, so obviously it can be considered to be m raised to the power 1, right? And then from that we'll be subtracting p plus q minus 1 divided by 2q, right? And that is what we do here. Okay, now, children, when we take an LCM in the numerator here, right, we will now get 2q, from which will be subtracted p plus q minus 1. Now, on doing so, 2q minus q will actually give us q, and from that is to be subtracted p and plus 1, as minus got multiplied to all of these three terms of the fraction. Now we have 2q minus q, that's why. Then we have minus p and minus plus 1. Next, now, children, after this, what we do is we will now be talking about finally solving this out, and in solving that out, we now get here m raised to the power q minus p plus 1 whole divided by 2q, and the power of n, which was p plus q minus 1 divided by 2q, remain to be as it is. Next, now we have to prove that. That means what we had to prove, we are now going to look that up, and in that, children, we have to prove the pth term to be equal to what? The pth term to be root of mn. Now we get ahead and we try to prove it. For that, first what we do is we now talk about what the pth term is going to be. It will be a into whatever is the common ratio raised to the power p minus 1, as it is the pth term. Now further here, we keep the value of a as we found out, right? That is this. Okay, and then we also keep the value of r that we found out earlier as m upon n raised to the power 1 upon 2q, and we put its whole power to be p minus 1. Then further we solve out the powers like this, that we have m raised to the power this power into m raised to the power p minus 1 upon 2q, which can be written, and then further we have n raised to the power p plus q minus 1 upon 2q, and in the denominator we have n raised to the power p minus 1 upon 2q. Now further what we do here is we will now here be using the quotient rule, and here we'll be using the product rule. That is, a raised to the power m into a raised to the power n becomes a raised to the power m plus n. As such, both of these powers will get added, something like this. And as we have a raised to the power m divided by a raised to the power n to be equal to a raised to the power m minus n, so keeping the base n to be the same, from this fraction we'll be subtracting this fraction. So next, now we talk about the sum of both of these, as the base, that is the denominator, is exactly the same. So as such, the numerators will simply get added. So here we will have minus p plus p, which will get cancelled, and then we'll have plus 1 minus 1, which will also get cancelled. Thus we'll be left out with q upon 2q, right? And there, thus q and q get cancelled, and we just left out with 1 upon 2. Now if we talk about the powers of n, we have here again the denominator to be the same. So as such, the LCM is also going to become equal to 2q, and in the numerator we have p plus q minus 1, to which is going to be added minus times of p minus 1, that is minus p plus 1, right? So plus p minus p gets cancelled, and then minus 1 plus 1 gets cancelled. You are just left out with q upon 2q. Again here we will have q and q getting cancelled, and thus you'll just be left out with n raised to the power 1 upon 2. Now here, children, you require to remember a rule, that is, if you have the product of two numbers a into b, which is whole raised to the power n, then that will become a raised to the power n multiplied with b raised to the power n, right? So here too, what we can do is, if we talk about already this being applied, that is m raised to the power 1 upon 2, n raised to the power 1 upon 2, we can obviously write by this rule m into n whole raised to the power 1 upon 2. Next then, as the power is 1 upon 2, it means that it is root of that number. So if you have a raised to the power 1 upon 2, that means it is root of a. So m into n raised to the power 1 upon 2 will mean that it is the root of mn. Now here I told you one thing more, that if you have the power of a to be 1 upon 16, it means that it is the 16th root of a. So this is all, children, that I have for you people in this part. Obviously there's the second part which is left out, and for that I like you people to click on the link which is there in the description, and then you will get to that sum too, because if I keep too long a lecture, I'm sure you people will be found snoring, and I don't want that. So children, this is something which is very important for your class 10. If you have geometry progression in class 10, like in ICSE, this is important for the IB board, where we talk about again sequences and series, where we have GP, that is the geometry progression. Then we have IGCSE, we have CBSE, all having it in class 11, and this is considered to be one of the important sums. So make sure you understand this all, and immediately after understanding it, do a practice. That normally I call to be CWDA, that is class work done again. So I expect all of you people to do a CWDA immediately after you have seen how the sum is to be done. If in once you can't do it, that is you have to look up the solution, make sure that you do it once more. Right? So children, that is all from my side. I am Saurabh Kumar Dutt in the Mathematics Helpline. I hope you people must have liked this lecture. What was something special that you understood and you liked in this lecture, and which is the topic in which you have a problem? Do write it in comments. Moreover, if you have done this CWDA, that is this sum practice again, right, you can send it in my email ID, themathematicshelpline@gmail.com, where I, by getting your email ID, will be sending you more stuff which is of your requirement. So make sure, children, that you also subscribe to this and you like it if you really liked it. If you didn't like it, you can write a comment that way also, and further you can share it to your friends so that more and more children can benefit, because I have a target to make 1 million, not students, teachers who are capable of teaching mathematics, so you can earn while you learn. Right? Bye. Meet you people soon, and make your mathematics really strong. Bye.